Okay, thanks for being here. So, what's the point of talking about mainframes in a Java conference? It's because these things are still very much alive. It's very likely that your last credit card payment was processed by a mainframe. Your last train ticket, your last plane ticket, and so on. So I'll try to give you a very quick feeling about what these things look like. So a mainframe is what you see on the picture here. It's built like a large fridge. It's very expensive. It's very powerful. It has a reputation of reliability. The thing you need to know in order to understand the peculiarity of mainframes is that they are backward compatible with all this. On the left, you see a tape drive. You see the legacy on mainframe. When you want to create a file, you have to tell if the file is going to be located on a type or on a hard disk. In the middle, you see the front panel of the first IBM 360 in 1964. Interestingly, all the lights you see represent the value of the bits inside the processor. They were doing this kind of things at the time. The legacy of this is that the processor architecture of a mainframe is still compatible with this. Okay? It has nothing to do with anything you know. It has nothing to do with x86, ARM, or whatever. On the right side, you see core memory. This is an array of threads, and at each intersection, there's a small TOR. Each TOR is 1 bit. This means that memory was very scarce and very expensive. And you see the legacy of this all over the place when you program in a mainframe. For instance, names are always at most 8 bytes, and saving 1 byte is something. It's also backward compatible with this. This is a punch card. This is the very early way of entering data in a computer. On the right side, you see a typewriter where whenever you type a card, it pushes holes into that card. 1 card is 1 line of code or 1 record in a file. Okay? So 1 program is a stack of cards, like you see on the bottom right. People always used to trace a diagonal line on their stack of cards for one specific reason: is when you drop your stack on cards on the floor, you need to put it back together in the right order, otherwise you're dead. Okay? And they also write the name of the program and so on the side. So the legacy of this, of course they don't use this anymore, but the legacy of this is still very present. First in the fact that everything is column-based. The programming languages are column-based. The data is mostly common-based. There's also the fact that it uses EBCD encoding instead of ASCII encoding. I'll get back to this later. Also, this is also the reason why you see capital letters all over the place, because the early punch cards didn't have enough room to store small letters. Okay. So basically, the world of mainframe is an entirely different vocabulary. On the left are a lot of terms that you are all familiar with. Everything around Java, Linux, this is your everyday vocabulary. On the right side is the everyday vocabulary of a mainframe programmer. And there is no intersection between the two. Okay? So the first difficulty in understanding a mainframe is this vocabulary. Beyond that, I mean, it's still software, it's still programming, so the concepts are always a bit similar. So let's be a bit concrete. I'm going to show you how to create a file. So in mainframe, it's called allocated dataset. In the shell, on a mainframe, this is called the JCL. So this is a JCL job, which does more or less the equivalent of this line of in a bash on a bash command line. As a Java programmer, the first thing that is going to be difficult, if you want to read this, is that this is not a comment. Okay, so try to forget everything you know and try to imprint in your mind that this is not a comment. Okay, in contrast, this is a comment. So the color, I hope the colors help a little bit. So this is a job. It's the only way to run a program on the mainframe. So a job has a name. It has a number of attributes. I don't even know what they mean. And it has a number of steps. This one has just one step, but you can have several steps. That's the name of the step. And each step runs a program. This is the name of the program. So just like on Bash, on Linux, you have a number of common commands that you all know by heart, like cat, cp, ls, and so on. On the mainframe, you also have a number of programs that play similar roles and that everybody knows. Okay, the names are very strange. It's mostly because you're not used to them, because there are some regularities, there are some patterns. Right? So it's not that obscure when you get used to it. On Linux, a process has one standard input, one standard output, and one error output, and this is fixed. On the mainframe, you can have as many inputs, outputs as you want, but you have to declare them here in the JCL. Yeah. And now these are the attributes of the file we are creating. And before I can explain you the attributes, I need to show you what does the file system look on a mainframe. So first of all, as I said, everything is record-based. So when you create a file, you have to specify the record length, the record size. And actually, most of the data that you will find in practice on the mainframe fits this model, is actually record-based. It's only in the case where you have a text file, something with a variable length, that you need some tricks to accommodate these restrictions. A file can have a number of access methods. If a file is sequential, it means that you can ask, give me the next record. If a file is indexed, it means you can ask, give me record number 10. Okay? So a file on mainframe is a bit something between a file on Linux and a database, in fact. It has some aspects of both. Some other attributes that you can specify when you create a file is, do you want to share it or do you want to have exclusive locking for you? Is it temporary during the job? Do you want to delete it at the end of the job? Do you want to keep it? And so on. There are lots of attributes of this kind. The file system is not hierarchical. When you see a file name like a.b.c, it does not mean that there's a directory named A, which contains a directory named B, which contains a file named C. That's not, no. This is just a naming convention. It's one file called a.b.c, with, of course, limitations in the length of the name. Okay. Another major difference is that on Linux, you have this idea that everything is a file. You use the same API, whether you want to read data from the disk, whether you want to read from the keyboard, whether you want to read from the network, from a socket. Everything is a file. That's not the case on mainframe. On a mainframe, okay? All these uses will use. You will use very, very different ways to do these different things. So I mentioned the ABCD encoding. That's the table, the encoding table here on the right. It originates from punch cards. And punch card, the earlier punch card had several constraints. First, they only had 6 bits. And then they have these constraints that you cannot put too many holes next to each other on a punch card, otherwise the card will tear away. Right? Yeah, but that's a reality. Right? So the encoding was designed so that there are not too many holes next to each other. So you end up with this encoding. One of the major differences with ASCII is that the letters are not contiguous. There are holes between some of the letters. So you cannot test something that is common when you use ASCII. You cannot test whether A is bigger than, whether some value is bigger than A and less than Z. So it's a letter. That doesn't work in ABCD, right? Sorting also doesn't work the same way as in ASCII, of course. There are hundreds of code pages, but that's the same as ASCII, so it's a mess. And it's especially a mess for programmers because many symbols that we use in modern programming languages are not part of the core ABCD encoding. So they are available on some code page, but not always, and when they are available, they're not available always at the same place. So when we talk about mainframe, we talk about Cobol because this is the most common programming language on mainframe. It's not the only one. PL1 is or was quite popular in Europe. Interestingly, there's still a lot of assembly language on the mainframe. So it is said that there are 800 billion lines of Cobol in production today. This figure comes from the vendor of Cobol compilers, so I'm not sure how much we can trust it, but in any case, it's a lot. Cobol was designed in 1969 with the idea to create a programming language that would use entirely English words. So that's why you end up with sentences, it's on purpose, okay? Like add A to B given C. In Java, you would write C equal A plus B. Okay? There's a lot of WS everywhere. This is just a naming convention. It means working storage. It means basically that this is a local variable. Interestingly, Cobol was designed exactly at the same time as Algol. Algol is the ancestor of a wide family of programming languages, including Java. But Cobol was designed entirely in isolation, so it didn't take into account the knowledge from the computer science community at the time, the knowledge about language design, about compiler techniques, and so on. So the result is a language that has a very poor support for structured programming. The programs tend to be very monolithic. There are lots of keywords, lots of dialects, and there are some, I will show you some funny gotchas. Okay? On the picture on the right is Grace Hopper, which is called, which is often called Grandma Cobol, which is the main creator of the Cobol language. She has an interesting life. I recommend you look at her page on Wikipedia. So the first thing to understand when you read or write Cobol is, of course, that it's column-based. So here you have 80 columns, as usual. So imagine you have this green screen, the thing they were using at the time, okay, 80 columns, 25 lines. The 6 columns on the left are reserved for line numbers. You don't have to use them. The columns on the right are also reserved for whatever you want. They are not part of the actual program. The program is in the middle. The column 7 is a very special and very important column. If you put a star in column 7, it means the line is a comment. And if you put a dash, it means it's a continuation. Because whenever something is column-based, then you face the problem that you may want to write a line that is longer than what is actually available. So what you do in this case is you do a continuation. So you put a continuation marker in column 7 on the next line, and then you can continue writing your code. Okay? And then in the middle, you see that you still have two areas. I don't want, this is a bit technical, I don't want to dig into it. But the program is the part that you see here in the middle. So Cobol has a very specific way, I mean, compared to the languages that you are familiar with, has a very different way of specifying data declaration. It's all based on picture declaration. So this is an example of a picture declaration. S stands for the sign. 9 stands for 1 decimal digit. V stands for the decimal dot. So here we have something that possibly that has a sign that has 1 digit before the decimal dot and 2 digits after the decimal dot. Okay? So below you see how this would be displayed. Okay? A picture clause tells two things. It tells how to display the data and how to interpret it in memory. So by default, this would be stored in memory as 3 ABCD characters. F1 is the ABCD code for the symbol, the letter 1. F2 is the ABCD code for the letter 2. And F3 is the symbol for the letter 3, but the sign is encoded here by changing the F into D. There are many possible encodings. Okay? Another one is part decimal. The idea here is that 4 bits are enough to store 1 decimal digits, so you part them. Okay? So 1 digit takes only half a byte, and the remaining half byte is reserved for the sign. Okay? You can, of course, use binary. Okay? So this is the representation you would see in Java. The same. Okay? So there are lots and lots and lots of picture clauses, but basically the idea is always the same, like here. Okay? Then you have compound data. So this is something a bit like a struct in C. The difference is that languages like C, Java use braces to mark the scoping. Okay, Cobol doesn't use this. Instead, Cobol uses level numbers. So anything that is at level 5 here, 5 is greater than 1. So everything at level 5 is included into level 1. Everything at level 10 is included into level 5. This is what they use. This is the equivalent of using braces. Okay? So this is like a big record with a number. So each elementary item is defined by a picture clause. Okay? And it contained a subgroup or substructure with year, month, day. You can also define things like enums. They always have some tricks. So the trick here is to use a special level number. 88 is not just a level number like any other. It means that the values are the enumerated values here. Okay. There are 77 is also a special level number, and so on. Okay. And then you can have redefines. Redefine is a bit like a union in C, where you can interpret the same memory area in different ways. So here we say that at level 5, we say that, well, this is a date. It consists of a year, a month, a day. So in total, it's 8 bytes. And then we redefine it, so we give it a different name, but for the same memory area. And here we say, no, after all, this is one number with 8 digits. Okay? So you can access it in both ways. Okay? Anything goes. So the compiler will not prevent you to reinterpret a date as a floating point number, for instance. Okay? So it's up to you. Yeah. A feature that is often, very often used in Cobol and is quite different than languages like Java is that when the field name is unique, you don't need to prefix it with the structured name where it's contained. Okay, so here WS month appears only once, so you don't need to prefix it with WS year, WS date one, and WS description. Okay. You can if you want, but that's not mandatory. So Cobol statements look like sentences like this. Okay, move or add. Actually, when you look at real Cobol programs, they mostly move things around. Okay? Cobol programs don't tend to not do a lot of complicated computation. You know, they produce invoices and these kind of things. However, the move statement. So move is a kind of affectation in Java. Okay, A equal B. Okay? Except that move can be very complicated because you can move something into something with different picture clauses. Okay? So the move statement is going to take care of, do I need to add padding? Do I need to truncate something? Do I need to convert things? Okay? So one move statement can be actually quite powerful. Okay. And notice that there is a dot at the end. It's important, and I will come back to this later. Originally, the only branching statement in Cobol was goto. Okay, goto and if then else. Some more structured statement came recently. That means like 20 years ago. But they still mostly use goto. Right? There is something called perform that is a bit similar to calling a function, except that there's no call stack. Okay, so there's no recursion, and you can see if you have two perform statements in one after the other, you will not unwind the stack. You will not come back to the same place. Right? It's a bit strange. And this works inside programs. Then there's the call statement where you can call another program. So this is actually used a lot because programs are very monolithic. They tend to do one thing. So it's very common to have one program called another program. And what's interesting is that the program is resolved dynamically. So the name of the program that you call can be in a string that is evaluated at runtime. Something also peculiar to Cobol is that there are many language extensions. So a language extension is anything between exec and exec. There's the SQL extension. This is very common. This is used all over the place. Between exec SQL and exec, you have an SQL query. It's a bit similar to JDBC in Java, but there's a major difference. In JDBC, you give it a string. So for the compiler, a string is just data. The compiler doesn't understand what is in the string. In the case of Cobol, it's part of the language. Okay? So Cobol knows that here name refers to a variable. The Java compiler doesn't know that column name refers to a variable. Another common language extension is called kicks. You will also find kicks all over the place. Kicks is a kind of extension to the original operating system. The operating system was providing low-level services. Kicks provide services of a bit higher level. So, for instance, you can send or receive text from a screen. You can have sophisticated read and write statements in files. In this case, you can read an indexed file. Okay. And there are, so these are the two most common language extensions, but there are many, many of them. And it's common for a compiler vendor to define their own extension. So just for the fun of it, let's look at a few Cobol oddities. Cobol has an alter statement. So you can write a program when you say, go to label 1. And then later, you can execute the alter statement. And the alter statement says that, OK, from now on, whenever I say go to label 1, no, instead go to label 2. So hopefully it's not used anymore. I guess it's banned everywhere. But this is very typical of self-modifying code. You want to save one byte, one comparison. So you do something, and then the alter statement will go patch into the code to modify the destination. Okay? This is something, self-modifying code is something that is still pretty common on mainframe, that you can do on mainframe. You cannot do this on Linux. When you see assembler code, you often see self-modifying code. Can you spot the difference between these two programs, or these two fragments? The dot. Okay, the dot is not at the same place. And the dot terminates the scope of the if. Okay. So in the first case, the two lines are in the scope of the if. In the second case, only the first line is in the scope of the if. Okay. So you have to be very careful about this. Recent, so again, recent with quotes, recent versions of Cobol added construct like end if, right? That it just didn't exist in the first versions. So it makes this problem disappear. But there are still places where the dot is important, and you still have to know about it and be careful about it. So Cobol is not the only language, okay? It's the most common language on the mainframe. There are many others mainframe-like languages, like PL1, RPG. They have very similar concepts, like the picture close and so on. They tend to think in the same way as Cobol. But if you want, it's also possible to run Java or C++ on the mainframe. Okay? But of course, there are some peculiarities. If you want to open a legacy file, a file from the mainframe, you have to specify the record length. It's most likely that the data you will find in these files will be encoded in ABCDIC and not in ASCII. And to launch your program, you will have to write a JCL job, because that's the only way of running a program on the mainframe. Right? So it's possible to run Tomcat, WebSphere, and so on. In practice, it's very uncommon because it's very expensive to run things like this on the mainframe. Right? So in practice, you will see Java or C++ only for gateways, only for interfacing Cobol application running on the mainframe and a Java application running on a Linux server somewhere else. So what is the reality, the everyday experience of working with mainframes? What people tend to like about mainframe is the reliability. So there's a high reliability at the hardware level and also at the OS level. Basically, everything is a transaction. So it's very difficult to break something because you can always fall back to a previous version. Okay? There's a lot of logging everywhere and so on. The applications themselves, however, tend to be quite fragile. And the reason for this is that there's a lot of low-level overhead. So it's very difficult to write a program without being aware of the exact memory layout. Right? Cobol makes you think in terms of memory layout, for one. Okay? The same for file. Often you must be aware of the calling conventions and the stack manipulation because you have several ways of calling programs that do not use the same stack conversion, the same calling convention, and some pop the start, some do not pop the start, and so on. You must be aware of this, otherwise everything crashes. Okay? You must be aware of something called A mode. On the mainframe, you can have a modern 64-bit program that calls an older 24-bit programs, right? and they can work together. But you need to be aware of the size of the address. Right? So yes, they are compatible with 24 bits, and it's not unusual in an application to have a mixture of Cobol code and assembler code. Yeah. There is something that you will hear all the time if you use a mainframe. It's called an abend, abnormal end. You can think of it a bit like a Linux signal. So abend OC4, which is called protection exception, is more or less the equivalent of a segmentation violation, SIG-SAGV signal. Okay? The difference is that there are thousands of different abends, and they are all pretty well documented. So when something crashes, it makes it easier to identify the cause of the crash. Okay? And this in turn turns into a development practice which they call code until it works, because you write something, you expect that it will crash somewhere, you look at the abend, it tells you where to debug and so on. So programming on the mainframe is a totally different methodology. So there's the traditional way, which is still relatively used because people who have been coding on the mainframe for 40 years, they don't want to change their habits. Okay? So, for instance, there is no code repository. They store the source code somewhere as they can, but an application, unlike a Java application where you have thousands of classes, thousands of files, and so on, they tend to be mostly monolithic. So it's less of a problem. But still, when you ask people, it's very common that they have lost the source code or they don't know which binary corresponds to which source code and so on. There is no DevOps, of course, no automated testing. what they do instead is a mainframe can be configured with several regions, what they call regions. So they have development, test, production, typically. So they try something in development, move it to test, and then move it to production. And traditionally, also, they don't have IDEs. The only thing that they have is the green screens, 80 columns by 24 lines. And people who are used to this are actually quite efficient. So you don't have to code this way because a lot of third-party providers are offering modern tools. You can use JIT on the mainframe. So typically, JIT will sit on a machine outside the mainframe and will push or pull things using FTP, for instance. But if you want to use modern tools, it's possible. Common interesting stories about mainframes. These are real stories, okay? The entire business of a major company relies on a 24 bits program that was compiled in 1972, but they've lost the source code. Right? But it works, so you don't touch what doesn't work. What works, sorry. Or it's written in assembler, but not so many people are able to read mainframe assembler anymore. Many of them left after Y2K. So Y2K in the year 2000 was a major event in the mainframe because to save 2 bytes of memory, they were writing dates on 2 bytes instead, on 2 characters instead. Sorry, 2 digits instead of 4. And when year 2000 came, they had to fix all their code. So a lot of people stayed until there, made a lot of money in the process, and left after Y2K. But the idea is the general idea with mainframe. So you can see is if it works, then don't touch it. So you can see as a benefit. Okay? It works. Do you know code that was written 50 years ago that still works? Yes, on the mainframe. On the other hand, it is very difficult to maintain, to upgrade if you want. So the question that pops up all the time is, should we keep the mainframe? So there are advantages to having a mainframe. One is stability. Just what I said, you wrote something 50 years ago, it still works. It's reliable. I didn't talk about this, but mainframes are also famous for security. And they are quite powerful. The cons, first there's the costs. So if you thought that the cloud was expensive, then think again. Because when you have a mainframe, you have to buy the machine, and then you have to pay to use it. Maintenance is also expensive because coding in Cobol leads to long development cycles before you can have a change in production. And also because it's difficult to interface with modern technologies. For a large company, it's not surprising to talk about a number of $100 million a year to run a mainframe. It's a lot of money. The other thing that people are totally panicking about is the lack of talent availability. So we have all this code, Cobol, assembler, PL1, whatever, that's running on our mainframe, that's running the core of our business, and nobody can read it anymore. What are we going to do? Right? So the CTOs who run mainframe are making nightmares about this. But it's very difficult to move away from the mainframe because there is a very strong lock-in precisely due to the fact that it's an entirely different world. It has its own technologies that are totally different than what we all know. I thought it would be interesting to raise the question. Yeah, why not? Why not? We can raise that question. It's a bit ironic, but maybe not that much, right? If you have some expertise in something in banking, whatever, plus you have knowledge of Cobol, knowledge of mainframe in general, you can expect a big salary. There's a huge demand for people like this. You can also expect job safety, because 800 billion lines of Cobol are not going to disappear anytime soon. You can start a career in Cobol right now, today. When you retire, there will still be a lot of Cobol around. People tend to be afraid of the mainframe because it's an entirely different world. I don't know, I don't understand. That's true. That's true. Mostly the vocabulary is totally different. The reality is that it doesn't take long to become familiar with it. And then there's Cobol, I don't like Cobol, it's not very sexy, it's too verbose, I don't like it. Yeah, but, okay. It's in the eye of the beholder, I would say. Okay. More important than the language or the technology that you use is the environment, the people you work with, what your business is doing, and so on. Okay? So maybe this question is not as ironic as it may sound. Right? So, and lastly, just a quick word about me and what we do at LZ Labs. We do something called the software-defined mainframes, which is something that allows to run mainframe application in a Linux box. Okay? So, in a few words, there's a duality between the mainframe and Linux. So, everything you can do on the mainframe using the traditional mainframe UI, you can also do it on Linux from the command line, and vice versa, both ways. You can take binary code, mainframe binary code, and run it directly on Linux. Or you can choose to take your source code, if you still know where you stored it, and recompile it to an x86 binary. Right? Or you can do a combination of both. They will be able to run together. Once you have done all this, then you can decide. It's up to you. You can decide to do future development on Linux, to be Linux native in C, C++, Java, whatever. Right? And you may also want to modernize the source code itself, like converting Cobol to Java. Right? So if you're interested in this, you can have a look at our website, and you can find me somewhere in the corridor if you want to talk about this. Okay. So I hope we have some questions. Let me find this. What is the reason that mainframe programs weren't rewritten to modern languages? It's difficult. There are several options. One option is to rewrite from scratch. Okay? You throw away everything you have, you try to, and you rewrite from scratch. Experience shows that it doesn't work. We have seen many people trying to rewrite 2 or 3 times, and then they abandon. The thing is that there is a lot of important information that is encoded in the legacy source code. And you cannot afford to lose it. And when you write from scratch, you always lose a lot of things. There are a number of vendors that provide or that claim to have automated tools to convert like Cobol to Java. Most of them are quite pathetic in the sense that they produce what we call Cobol, which means Cobol encoded in Java. So if you look at the code, yes, it's Java. The compiler will compile this happily. If you show this to a Java developer, it doesn't make sense. Okay, nobody can read it, understand it. It's just not idiomatic, as we say. And there is no point in. I mean, the purpose of converting to a modern language is to have your code to be more maintainable. But if you do this, it's less maintainable. So there are ways to convert things in Java that is readable, but it's not it's not much on the market, I would say. If it was easy, people would have done it, for a long time already. What happens if 88 is a scope number 2? 88 is not a normal scope number. I'm not a Cobol specialist. I might be wrong about this, but 88. Oh, you don't. Sorry, you don't see the. You don't see the questions. Why you don't see the questions? I see them on my screen. Okay, I'm the only one to see the questions. Sorry, I don't know why. Doesn't work. How big could be the group of people who can operate service in code on mainframe? Are there new things done, or will world relies on legacy? I'm not sure I understand the question. There are lots of people around the mainframe. Is it possible to emulate mainframe on my laptop? Yes, using Docker VirtualBox. No, there is something you can Google for it. There is some. I forgot the name, but yes, it's possible. Can you share the slides, please? Yes, of course. IBM was creating mainframes for Java some time ago. Are they in use? I don't know much about it. I'm not sure they. Do you mean mainframes that were dedicated to Java? I know they offer Java on ZOS, so on the normal mainframes. How would you compare performance of mainframe and the software-defined mainframes? What are the technical parameters of your Linux bots? Well, as usual, the answer is it depends. It depends on the hardware, of course. I mean, you could run it on a Raspberry. It also depends if what is using the time is in your application or is in libraries, because the libraries you can provide them as Linux native. Right? So it really depends on a lot of things. In practice, it's not a problem. Do you think that AI may be able to convert the 800 billion lines of code into some of the current tech stack anytime soon? I'm not a guru, but I don't think so. I don't think so. You need, when you convert code, you need it to behave in exactly the same way. Something approximate just doesn't work. It has no use. And I don't see how AI could provide an exact translation. Sometime ago, the big improvement for mainframes was Linux tooling on host. Are these OS upgrades for mainframes? There is a Unix version available on mainframes on top of ZOS. So ZOS is the most common OS operating system on the mainframe. You can install some kind of Unix over this. It's not Linux, and you can run POSIX program. But I don't know much about it. Some time ago, the big improvement from what are the salaries for Cobol and mainframe development? Oh, you have to Google for this. I really cannot give figures. They're pretty good. How much your software-defined mainframe cost in comparison to normal ones? I have no idea. Actually, I'm a technical person. You should ask. You should ask someone in sales or something. Okay, and we're at the end of the questions. Thank you.